Okay, so I would like to quickly introduce myself. So I'm an solution architect working for Tata Consultancy Services. I predominantly work with a Microsoft 365 platform, and also if there is extension needs, we'll be doing that with Azure. I'm also a Microsoft certified trainer, and I'm currently located at Stockholm as of now. And these are my social handles: LinkedIn, Twitter. And if you've got any questions, right, you can contact me in any one of these handles. Right, and the next one is my these are my community contributions which I'm doing it. So for we have recently started an meetup group, Cloud Journey user group. It is our first event, and this is our first event. And I, along with my colleague Tirunao Karasu, we both have started this initiative. So with this group, we'll be sharing our experience with Microsoft 365 platform and also Azure services, different Azure services. And this is my blog. You can take a look at it. I have already written articles related to Microsoft 365 and Azure platform. And this is my YouTube channel. I've hardly a few videos on it, but I'll be whatever sessions we are doing it here. Part of this meetup user group will be I'll be putting that on my channel. So now let's take a look at the agenda. So this is what we are going to discuss. So I'll be starting with Raspberry Pi. So what is Raspberry Pi, and the IoT which I have done for this for these two apps, controlling from PowerApps and also the team presence slide. I've used Raspberry Pi for that. And after that, we'll be creating our first IoT projects with which we'll be able to control a light, turn on an LED light through the GPI open. So I'll be doing it from the scratch. We'll be adding all the required modules to it, right? And after that, we will see how to control a device connected to the Raspberry Pi through the Power App. And then at the next one would be the Teams presence slide. So based on your current Teams presence, available, busy, do not disturb, and it automatically switches the light based on your status. And at the last, we'll take up questions. So what is Raspberry Pi? I hope everybody knows what is a Raspberry Pi, but for me, to be honest with you all, I got to know it only few years back, one or 2 years back, I would rather say. Right, it is a very powerful credit card size computer, right, with which you can do a lot of stuffs. You can write programs on Python. You can write programs on .NET. You're using .NET Core or Scratch, and even with the Raspberry Pi, you'll be able to connect to the Raspberry Pi use from your Windows client. So I'll be quickly showing that as well, how to connect a Raspberry Pi from your Windows computer. And this is the schematic of the Raspberry Pi. It has got all these different ports. For example, it has got an HDMI port with which you'll be able to connect a monitor to it. And there are 4 USB ports with which you can connect a keyboard, a mouse, right? And also it has got an Wi-Fi adapter. It has got an Ethernet port, and also it has got a jack for audio, right? And this one is the power source for the Raspberry Pi. It is a 5-volt source, so you'll have to provide power to this one. And you can correlate this port to the motherboard of your computer, right? And what I've used for this project is it has got a 4 GB RAM, and here the port which you see here, the interface here, and this is where we'll be inserting the SD card. So the SD card, it is like a hard drive when you compare it against against your laptop or a desktop machine. So there are SD card will have the operating system image. It can be Raspbian, the official operating system from Raspberry Pi organization, and you can also run Ubuntu on it. So Microsoft has also got a version for IoT core, Windows 10 IoT core. But I don't see any more investments or development happening from Microsoft, right? And also the main component used for the IoT automation or is this GPIO, general purpose input and output. All right, so we use this interface for us to control the devices. Right, so if you have to control devices, you can set the mode to output, and if you have to work with sensors, right, so wherein you receive the signal, and you can set a pin number to input. So the two apps which I have done here, which I'll be demonstrating on this session, it is going to be output, not input. Maybe on the future sessions we will also do collect data with the help of sensors. Let's, for example, if you have got a temperature which needs to be measured and you have to send that to the cloud, in that case you'll have to set the pin GPIO pin to input. So it can be any pin here, whichever has got GPIO here, right? And apart from these GPIO, we have also got voltage pins. So the pin number 2 and 4, it gives 5 volt, and the pin number 1 here, it gives 3.3 volt, and there are grounds as well. So yeah, the 6 number is ground, and 9 and 14 is ground. Okay, so I'd like to quickly also let you know a story before I go to the next slide. So where I got inspired with this IoT when I was in college, right? I went to a technical symposium, and the guys there, they did a project to control lightings from the computer, and it was through a desktop computer. Right, it was though it was not on internet, but it was through a Java program, so some program running on the desktop computer, and with which they were able to control the lightings. I was quite fascinated with that, even though at that moment I had a computer with me, but I was not very good, or I was not mentally prepared to open the cabinet and get all the wires and do something on the motherboard, right? But with the Raspberry Pi, it is a low-cost computer, and you can easily afford it, with which you can do a lot of stuffs. Right. So I will go to the next slide. So here we'll be creating our first Visual Studio Console application, with which we'll be controlling a pin from the GPIO, through which I'll be turning on an LED. Right. So whenever we set a pin output as high, and you get actually 3.3 volt, with which it is more than sufficient to turn on an LED, and it is what we'll be doing it now on this session. That is going to be our first topic here. And this is, if you look at the prerequisite here, I've used a Raspberry Pi 4, and also it has a Wi-Fi adapter. It is connected to my router, internet router in my home, and also the other prerequisite, you should be knowing the IP address of the Raspberry Pi. Right, you can easily get the IP address of the Raspberry Pi either by connecting the Raspberry Pi to your monitor, and with the command I'll be showing it, you can get it, or you log into once your Raspberry Pi is connected to the internet, and from your router page, you can get the IP address which has been assigned to the Raspberry Pi. And the next one, I've also used a GPIO extension board. and also a GPIO cable, which actually connects the extension board to the Raspberry Pi, right? And I've used the extension board on the breadboard. So that is what I've used here to connect all the pins on the Raspberry Pi. And I've used few resistors and LEDs and jumper wires to create connections. And I have also used a relay module, even though I was not I'm not controlling an high powered device, but I've used a relay module to still control an LED. Right, but you can control a high power device with a relay module. And I've used an 4-channel relay module, and if time permits, I will show you the schematic of the relay module. So the current configuration, the operating system which is running on the Raspberry Pi is Raspbian OS. It is the official version of the operating system. And also it has got .NET Core 3.1 installed. So I'm a .NET guy. So all my years I worked with .NET. So because Python is also a popular language used in IoT for controlling devices, getting the sensor data. Right, but I've chosen .NET Core, and the other advantage is Microsoft created an all-platform version, so it is easy now to connect to run in any operating system. And then we should also have the SSH enabled, because all this particular project we are going to be now creating. We will be doing or connecting to the Raspberry Pi remotely with the Visual Studio Code. The next one is you should also require root permissions. Right? It is, and if you correlate with Windows, it is something similar to the admin permissions, right? So to control or to send signals through the GPIO, to send be it input or output, you require root permissions. And then here, coming to the Visual Studio Code, you need a couple of plugins. The first one is remote development. So it is a plugin developed by Microsoft, with which you can connect to Raspberry Pi, OS, Linux, etc., etc. You'll be able to remotely develop applications. And also, I've installed another plugin called as NuGet Packet Manager, with which you'll be able to add the packages, right? Reference it on your console application, right? And then the next one is so this is the NuGet package, which we'll be adding it on our first project. So this package is from Microsoft, which helps us to control the device, the GPIO pins programmatically. So now I will be exiting the presentation mode. So let's quickly watch the demo. I'll be turning off my video. Already turned off. Okay, so let's create it. And first, as a first step, I'll be quickly showing you how you can do an RDP, right, to the Raspberry Pi. You can use MSDSC, the terminal service from Microsoft. So this one, 192.168.0.141, it is the IP address assigned by the router to the Raspberry Pi. And you'll have to just put the address here. And before you can actually connect your Raspberry Pi remotely, and you'll have to install a software called as XRDP. And that particular software needs to be installed on your Raspberry Pi, right? And after that, you'd be able to take remote. I'm clicking on connect. So the username I haven't changed. It is the default one. Yeah. So I'm now connected. So the screen which you're currently seeing is the Raspberry Pi. Which has the Raspbian OS running. Right, so I would like to quickly show the configuration which requires for making an secure shell for you to enable remotely develop applications. Right, so you will have to go to the preferences here and then Raspberry Pi configuration, and you go to interface. So this one, secure shell, it has to be enabled, and only with this, and if it's by default it is disabled, and after you enable it, only after this step you'd be able to remotely develop applications. Right, so now I'll be showing another software called as Putty. It is also available for download, and it is created from Windows. Right, so with which, and this with this software you'd be able to connect remotely to your Raspberry Pi, to your remote device. It's again a command line interface. You'll have to just type in the IP address of the Raspberry Pi, 192.168.141. So now open, you type in the login and then the password. Yeah, so it is now connected. You can now see I'm on the Raspberry Pi, home Pi. You can also, if you want to know the IP address of the Raspberry, this is what you'll have to do. Host name hyphen space hyphen capital I. You get the IP address of the Raspberry Pi. So after this, let's go ahead and create our first project from Visual Studio Code. Yeah, so I'm starting the Visual Studio Code. I have already installed the remote development plugin. So Control Shift and a P, and we are now going to connect to the Raspberry Pi. I have already created the configuration, the host for this address, for the same IP address of the Raspberry Pi. So with this, you select the IP address and then type in the password for the Raspberry Pi. So it is now connected. You can see we are now connected to the Raspberry Pi remotely through the Visual Studio Code. So, and if you open the terminal, you can see we are on Raspberry Pi. So home Pi. So let's now go ahead and create our first project. Right, so and before that, I'll be showing the different plugins which I have already installed, the extensions. Right, you can see there are actually two versions. One is the local version. The other one is so these plugins are installed on the Raspberry Pi. So I've got NuGet Package Manager installed on Raspberry Pi. So with this, we'll be able to add the NuGet package called as system.device.gpio. So let's add that first. Right, and before that, we'll have to open the folder where we are going to create the console application. So it is whatever you see here, it is on Raspberry Pi. I'm selecting IoT in .NET. So this is the folder which has been created on the Raspberry Pi, and I'm going to create a new console application here on this path. Type in the password. Yeah. So let's create a new folder. First project. Yeah, so the folder is now created on the Raspberry Pi. So copy the path and then switch the directory to that particular new folder. So once this is done, run the .NET command .NET for creating the console application, .NET new console. And you'll be able to run this command only if your Raspberry Pi has got a .NET Core installed on it. So the console application is now created. You can see the program.cs file, etc. Now let's go ahead and add the package through the extension Nugget Package Manager. Control Shift and a P, add package, and we're going to add system dot device dot GPIO. Right, so we have so this is the one, and what is the version? So one, and to which project we are going to reference that first project. Right, so now we have imported the Nugget package system.device.gpio. So let's go ahead and add some code so that we can control turn on an LED through the GPIO pin. So first step, add the reference for system.device.gpio, and then I've already have the code. I'm just copying it. Yeah. So here we are creating an GPIO controller instance class, and with which you'll be able. We are now opening the pin for pin number 22 on the GPIO. Right, and after that we are setting it as high. It means that it creates or it sends an signal to that GPIO pin, and it'll have the voltage 3.3, with which we'll be able to control, will be turned on an LED. And if this is set to low, pin value dot low, in that case, the voltage on the pin 22 will be 0, right? So there'll not be any voltage. The light will be turned off. So now let's quickly run it. And if you remember on my slide, so we require root permissions, right? Because we are now going to control the pins, GPIO pins. So we require root permissions. So but with this command, and you'd be able to provide the root permissions. So the user bin GPIO export and 22, and we are setting this as out, and it's going to be the mode is output, right? And if you're working with sensors, it needs to be in, right? So this is done. And now if I .NET run, right, I will also show the light. Yeah. So you can see here the light is turned on, which is connected to the GPIO 22. So this is the GPIO extension board, and this is the cable, whatever you see here, right? And this is the Raspberry Pi, right? It's got all the heat sinks, and this is where the GPIO pins are, and it's connected to the breadboard through the cable with on the GPIO extension board. The light number, the light LED connected to the pin 22 is now turned on. And if I now exit the application, the light will be turned off. Right, so I'm exiting it, and you can see the light is turned off. So now the reason we have used this command, right? As I said, it requires root permission, because we are going to control the GPIO pin, so we will have to use this command, right, to turn it on. So now the objects are disposed, right? Since we are using using statement, the objects are actually disposed. If I now run the application, you can see the exception. .NET run. It's now not going to turn on the light, but rather, so you can see the exception. Setting up mode to a pin requires root permission, and access to the path is denied. Right, to overcome this issue, we'll have to run this. There are other ways to handle it as well. You can log into your Raspberry Pi which has got root permission. So in that case, it's not required for you to run this command. Right, so I'll go back to the PowerPoint. Right, so our next slide is going to be, we'll be seeing how we can turn on the light from the internet with the help of a Power App. So let me make the presentation bigger. Yeah. Okay. So here, this is the architecture for to control the device connected to the Raspberry Pi from using the Power App. So let me turn on the laser pointer. So we have a Power App here. It sends a signal to a console application, .NET Core console application running on a Raspberry Pi, right, through a custom connector. And then the custom connector sends a message to the Azure Function. The Azure Function sends a message to the IoT Hub, and the IoT Hub is configured. The code for the IoT Hub is configured on the .NET Core application. And whenever there is a message on the IoT Hub, there will be, based on that message, the console application responds to it by sending corresponding signals to the different pins on the GPIO. Right, so we'll also take a code tour after this slide. Right, and here, so the reason why I've used a custom connector is because PowerApps has got a lot of out-of-the-box connectors. For example, SharePoint, OneDrive, and a lot of other connectors. But what we have written is an custom function. So I've used an HTTP trigger Azure function. So I'll be able to call that Azure function on the Power App with the help of a custom connector. I'll go to the next slide. So wherein I'll be talking on detail about the different components I've used for that application. So the first one is a console application. On the console application, I have this package system.device.gpio IO, which I've used also on our first project, which we have just created it. And also the next one, the Microsoft.azure.devices.client. Right. So this package, it helps us to read the message from the Azure IoT Hub, and once it is read, it deletes the message. Right, and we'll be able to read the message from the IoT Hub with the help of the connection string. Right, I'll be showing it momentarily. The next one is IoT Hub. We have got a device to be registered. Right, and once the device is registered, so the device which you're going to work on this context is the Raspberry Pi. I have already registered it, and once the device is registered, we send a message to this console application, which will keep waiting for it. Right, and also I'll be quickly showing an application, a Windows application called as Device Explorer, with which you'll be able to send a message to the Raspberry Pi, and then through the IoT Hub. Right, so and we also have an Azure function, and it has this package installed, Microsoft.azure.devices. So this particular library or a package, it sends a message to the IoT Hub. So it has got the SDK or functions to send a message. And I have an HTTP trigger function. The authorization level for that function is function, so it's not anonymous function. And we have got a simple custom connector which has got only one action. And then we have an PowerApps Canvas app. So let's now quickly take a look at the code tour. I will switch to the my Visual Studio Code. Yeah. Okay. The first one, we are importing the libraries. So whatever I've shown on the slide, system.device.gpio, and then Microsoft.azure.devices client, which helps us to connect to the IoT hub, receives the message from the IoT hub. We are importing it, and once that is done, and these are the different variables we are declaring it. The first one is the IoT hub host name. Once you have the IoT hub created, you'll be able to get that information. And then we'll have to have the device registered on the IoT hub. So I have registered the Raspberry Pi device, and then the key for the registered device, right? So that's what I have put in here, the device key, and the device name is my Raspberry Pi device, and then the pin numbers. I've used pin number 17 and 18. So I'm going to control two lights. The first light will be turned on or off through the pin number 17, and then the second light through the pin number 18. The next one is, well, we should also be creating an instance of a cancellation token resource. So it is from the library system.threading, and it is responsible for creating a cancellation token, right? And we need this. We'll be using this to receive the message from the IoT hub, right? And it is for this particular thread of the console application. And then we are creating an instance for the device client, right? And this particular instance we'll be using to receive the message from the IoT hub. And we are creating the new controller. This is almost, it is similar to what we have done on our first project. We are creating a new instance for the GPIO controller. We are opening the pins. The next one is whenever till a cancellation is requested on your console application, right? The program keeps running. That's why we have an while. And the next one is, so this particular line, received message, device client dot receive synchronous, and then this one is the cancellation token instance, which we have created the token of it, which we have created on our code earlier. So this one we'll be receiving it, and whenever there is a message, and based on that, it turns on or off the light, and after that, it will wait for a new message. And the next one is, so this line actually reads the message from the IoT hub. Okay, so here we have an switch statement. So based on the message, and if a message has got on number one, the light number one will be turned on. As I already said, there will be two lights which I'll be controlling it from the Power App. If the message is on, light number one will be turned off. You can see here we are setting the value to high, and if the message is off one, and we are turning the light off. And if there is an on two, we are turning on the second light, and same for the off two. And once the message is received, once it is read, and based on that, you send appropriate signals to the GPIO pins, and after that, you'll have to delete that message. Right, and this line actually does that. A device client.complete async. So now let's go ahead and run the program. So and before that, we'll have to open the pins. Right, the root permissions. I have used the GPIO 17 and 18. 17. And 18. Now .NET run. Yeah. So the device, the program has been started. So whenever there is a message from the IoT hub, you'll now be able to turn on or off the light. So I'm going to start the device Twin Explorer, Device Explorer. I've installed it on my computer, right? So this is the connection string from the IoT Hub. So I'll be quickly showing that from the Azure portal, right? So you can now, I will get this one. Yeah. So you can, so there are two lights, light number 1 and light number 2. So I'm going to send a message from here on 1. Yeah. So you can see the light number 1 has now turned on. And if I send a message which is off 1, the light number 1 will be turned off, right? So it is turned off. The light number 2, and it is connected to the relay module. So what we are doing is, and whenever there is a signal on the GPIO pin, it activates this relay, and so with the help of this relay, you can control an high-powered device. But here, I'm again controlling the relay board, sending the signal from the IoT hub, and with which I am turning on a different LED connected, but connected to the relay module. So you can look at my screen. I'm now going to send on to turn on the second light, and when I send this, it will turn on the relay. So the relay is now turned on. You would have heard a small sound from the relay module, which actually switched. Created the connection. The light number 2 is turned on. Okay, and now I'm going to off the light number 2. So you can hear the sound. The relay module is now turned off. You can see the light is now lit on the relay module. So this is the demo, and now I will quickly show the portal interface, Azure portal. So let me bring the portal. Yeah. So here, and this is the Azure web portal, and I've already created the IoT hub. IoT, yeah. So this is the hub which we have already created. It has okay, the shared access policies, and whatever I have used on the device Explorer is this key, right? And you get the connection string of the primary, the first one. So this is what I have used on the IoT device Explorer Twin. So this one, right? And once this is done, and you can send messages. Now I will I've used a Twin Explorer, a device Explorer, but you can also send that particular message and turn on the devices from the portal itself. So IoT devices. So you can see here I have already registered a device for Raspberry Pi. So in order to register a new device, it's very simple. You put in the device ID. It can be numbers. It can be alphanumerics, anything. So and once you have put in the device ID and save it, you're done. Right. So I have named it as my Raspberry Pi device. And from here, you can also send in message, right? So whatever I've sent it from the device Explorer, you can do so from the portal interface. And to turn on the devices, I have used this particular message to device, but you can also use direct method, or you can also create a device twin, right? And these are other ways wherein you can use to send a message to the device, and in our case, Raspberry Pi. Right now, so now I will quickly. Okay, so we are, and if you remember on the application here, console application, I've used a code at the connection string. So this is the key. and this is for that particular device, and you can have on a IoT hub, and you can have n number of devices registered, and you can, and whatever keys I have used on the console application is this one, the primary key here, and this is the device name which I've used, right? And I have used a free tier for the IoT hub, and whatever I've created on Azure, it is completely free, and you can per day you can send up to 8,000 messages, and if I turning on a light, so that is one message. If I turning off, that is another message. So similarly, you can use up to 8,000 per day without any money, and it is a free tier. Right now, I will show the Azure Function code. So whatever we have sent the message from the portal, Azure portal, and also from the Explorer, with which we were able to turn on the device. Right. So now we'll have to, in order to get this done from the Power App, what you require is an Azure function and a HTTP trigger one. It has got a very simple code. The connection string of your IoT hub, and then the device name. And it creates an a request HTTP parameter name, the on one, off one. So we are sending it on the HTTP parameter, right? And here this one is actually sends the message to the IoT hub, and this particular code. And I have already published it to the Azure portal, right? So we have this function here, function app, and the URL for that function app is this one, Azure. I have already created it, and all the code, whatever I'm showing it, I'll be publishing it on GitHub, right? So you will also get the code. And after the function URL, I'll be showing the custom connector, right? So I have talked about it on the slide. So I'll quickly show the custom connectors. Yeah, so this one, I have already created the custom connector. Let's quickly edit this, and I will give a quick walkthrough. So we have now the function ready with us, the Azure function, which sends a message to the IoT hub, right? So with that in place, and we, in order to call this from the Power App, and we have it's required for us to have this custom connector. Yeah. So here, and this is the host is nothing but the function URL's domain, which is this one. Yeah, this is the function URL. So this one is the domain of your function app. And next one comes to security, right? It's not an anonymous function, I have already said. And if you look at the connector, and if it is an anonymous one, you'll have to select no authentication. Since I've used the authorization level as function, and it has to be API key, and it also accepts OAuth 2. And if it's an username and then password, it should be basic authentication. And after that, the parameter label, and then the code. And if you see here, the code for this function, it is here, and it has got a parameter called as code, right? It will be on the URL. So that is why, and is it on a query or it is on a header, right? So in our case, it is we'll be using it on a query. And if I now right, and if you execute this one, I'll quickly let you know, right? So and name equals to on one, the light number one will be turned on, and if it's off number one, the light number one will be turned off. Right, so here, and this is done, and after that, the definition, as I already said, it has got only one action which will be using, which will be calling it from the Power App. Right, so here control device, one action, and the only parameter is name, right? So here is it the name equals to on one. So that is the only parameter. And if you want to expand this one, and it is a string, and whatever value we are sending on one or off one, it is actually a string, and that is why the type should be string. And that's it. And if I go to test now, and you can now quickly do a test after a connection is created, right? I will open the, okay, there you can see the light getting turned on or off, right? So on one, the light number one will be turned on. Yeah, you can see here the light number one is turned on. Off one will make it turn off. Right, you can, this is how I have done it. Now we have the custom connector in place. We are good to use it on the app. Right, so I'll quickly show how it is done. So I have already told you it is a canvas app, and this is an interface for controlling the light number one and light number two. And it's got two canvas control. And if you take a look at the code here on selector, once this is turned on or off. One second, if you go to on select, yeah, so this is the code, and the only prerequisite after we have that custom connector created is to add this connection, right? And if you go take a look at the connections here on the left side, and you will see that connection added. So what I'm doing here is, and if I turn it on, if it is turned on, right, I'm sending an I'm calling that custom connector IoT control device, and this is the action control device, and the message is on number one. And then if it is turned off, if it's the other way around, it is a toggle control I've used. And if the value is false, it goes to the next condition here, and wherein we are now sending as off number one to the name parameter, right? And I can now turn on or off, right? I've already turned on or off, and now if I turn on, I will also have this here. Yeah. So the light number one is turned on, and light number two is turned on now. I'm turning off the light number two, turning on the light number one. So the advantage here is, since it is an Power App and a no-code platform, anybody can create it without having a programmatic knowledge, right? You can easily deploy it and access it on your mobile. The only prerequisite is to download the Power App from the Play Stores, install it, you log in, and if you've got access to app, you can do this anywhere, right, from your mobile. And whatever I've used here, it is the web version, right? So this is done, and I will quickly show the relay module which I've used. Whatever I've used is a 4-channel relay. And here so this one is actually created for Raspberry Pi. It is a 5-volt relay, and we have the jumpers remote. I have already said that the voltage from the GPIO open, and if it is set to high, it creates only 3.3 volt. Right, and since this is a 5-volt relay, and 3.3 volt will not be sufficient. So in that case, what you have to do is remove the jumper here, and on the JDVCC, you give 5 volt that's again from the GPIO. When if you go back here to my first slide, right? So the pin number 2 and 4 has got 5 volt, right? So the 5 volt should be given to the JD VCC, and 3.3 volt should be given to the VCC here, and then ground to the ground on the GPIO, and then the GPIO pin. So in my case, it is 18. So that is given to IN number 1, right? So here, and whenever there is a signal IN 1, this gets turned on, and these are the terminals which you can which can be used to control an high-powered device. So it is like it is a switch, right? So whenever there is a signal from the power app and this relay gets turned on, it creates a contact, right? And the phase of your high power device has to be connected here, the neutral to the neutral, right? It gets turned on or off. And so this particular module, the 4-channel relay module, and it can the ampere is about it can have up to 10 amps. The maximum voltage is 250 50 volt. If it's DC, the maximum volt is 30 volt, and the amp can be 10 amps. So that is the maximum. So now I'll quickly show the second project, which is the Teams presence slide. So I'm not sure I'll be able to complete it in time. So I think you guys are okay in extending it to 15 minutes, 10 or 15 minutes. So it's
Yeah.
okay. Swap. Okay, one sec. Yeah. So here, what I've done is it is a again a simple project. So based on your Teams presence, and if it's available, the green light will be turned on, and if you're busy, the red light will be turned on. If you're yellow, right, the yellow light will be turned on. And on my project, I've just used 2 LEDs, the green one and red one. So what I'm doing here is it has got a console application running on the Raspberry Pi, right? It's almost the same concept. The only thing is it connects to the graph endpoint to check your presence. So there is an beta presence API with which you'll be able to get your current status. You'll have to make an get request. So this particular console application, it polls the graph endpoint once in 5 seconds, and it gets the status, your current status, and based on that status, it sends signal to the GPI opens, and then it turns the different colored lights. Right. So this is what the high level architecture, and these are the different components. So the Nugget packages, I've used the device.system.gpio as I've used on the previous 2 projects. The other one is Microsoft.identity.client. Right. So this actually helps us to call a graph endpoint. Right. And if you already if you have worked with graph, and if you have to call a graph endpoint, you actually require an access token. And this particular library helps us to generate that token. The other information here is I've used the device code flow. The reason being, the presence permission, the presence dot read, and you'll be able to get this permission. As of now, it is only delegated, right? And it has got no application permission. So I'll have to use the device code flow. I'll be quickly walking that through. And we also use the system.threading library. And this one is used to poll the graph endpoint once in 5 seconds. So we are basically creating a timer. And then the Newtonsoft.json, and this one will be helping us to parse the HTTP response, right, which we get it from the Graph Explorer, right? And this one system.net.http, it is used for sending a signal, creating a get request or a post request. And here, coming to the Azure Active Directory part, I have an app created on the Azure Active Directory, and it is a public client application app, right? And the API access given to it is the presence.read, right? So let me now quickly go and show the code. And before that, I will show the, if you already know, there is an service from from Microsoft for you to test the different endpoint. And right now, my status, right? Once you log into the Graph Explorer, once you sign in, and this is the endpoint I've used, beta, me, and a presence, and it is a get request. So right now my status is set to availability is not disturbed. It is nothing but it is red, and my activity right now is presenting, right? Because I'm presenting right now. So with that, okay. I would like to also quickly show you, and we actually get an access token. And if you log into the Graph Explorer, it automatically generates an access token for us. And if you copy it and you put it on the jw.ms utility, you get to know the different about the information about the token, right? And what are the permissions you have got, from which computer you have connected, you have called this, and what's your name, exit, and what is the app. So this is the default one, since we're using a Graph Explorer. And what are the permissions we have got, and if you, is from SCP, you can get to know it. And if you look here, and this has got a presence.read, and only with that permission I was able to get my presence status. Let's now quickly go to the Active Directory, and I will show the app created for it. So app registration. So I have already created this one, MS Graph device code flow. This is the app ID. The only prerequisite what we'll have to be doing is here, you'll have to add this on the redirect URI, this part. And then it has to be the account type should be accounts in any organization directory. And the next one is the default client type. It should be set as public client. And this is as of now a limitation, right? If you have to use a device code flow, it has to be set as a public client. Maybe in the future it may not be required, but as of now it is required. So the only permission which it requires is presence.read. And if you try to add a permission from Graph, right, and there are two types of permissions, and delegated and application permissions. And if you notice here, the presence.read is delegated, right? And so in that case, what it means by delegated is you'll have to log in order to call a Graph endpoint, and only if you log in, you get that information, you get the response. And as of now, the presence.read, it is not an application permission. An application permission is nothing but it acts like a daemon. And for using an application permission, you require also a secret. And once you have the client ID and a client secret, you can call any endpoints. It is not required for the user to sign in. It can run like run as a daemon, right, on any computer. Okay, so now let's quickly take the code tour. Yeah, so we'll start it. Yeah, so here the first one is we are importing the libraries, identity.client for making calls to Graph, for generating the access token, and then the next one is for creating the timer. Right, for making a HTTP request call, I'm just and then for controlling the GPIO pins. Right, so here create the variables, creating the variables. One is the client ID, tenant ID, which you actually get it from the app on your Active Directory. right? And what is the scope you require? The only scope for this particular application is presence.read, right? And the pin number 12 and 13, which will be controlling it. Pin number 13 is for setting it to green light, and I've got one LED for green and one for red on pin number 12. So here, so this particular line of code, it creates the access token, right? And with once we have the access token in place, you'll be able to call a graph endpoint, and if you have got permission, you'll get the response. And everything we're generating the access token is everything is taken care by the Microsoft.devices.identity .client. So this is what takes care of it, right? And if there is already a device code right in the cache, it'll take that, and if not, it creates a new device code with which we'll have to log in first. So you'll understand that after I run this application, right? So the next one is, yeah, so this particular code, it creates the device code for us, right? And after, okay, so the other thing to note here is, and whatever token you actually generate here, right, the access token, it is valid only for an hour, right? 3,599 seconds. Only for that period it is valid, and after that it expires, right? And with that token, you'll be no more be able to get a response for your graph endpoint, right? So what needs to be done is you'll have to run this line of code after an hour. Right, and if you're so you'll have to write accordingly on your program. You'll have to handle that on your program so that after an hour you call this line of code again to get a new token. So the next one is okay. So here is where we are creating a new instance for the timer, right? So we are creating a timer which will be running infinitely. So here a get user presence. It actually get the presence once in 5 seconds. So this is actually the code, whatever you see here. So the HTTP client from the class system.net.http, and we are making a get request, and to this endpoint, whatever I've shown on the Graph Explorer. So this is the one, and the token we are sending it on the headers with this one with this bearer, and once you do that. You'll be getting the response here. So the response, we are getting it here. And after you have the response, yeah, make an request. I think there is a mistake on the code door. I'll have to correct it. Right. So once you get the response, we are now turning on the different lights. And if your presence is available, what I'm doing here is turning on the green light and turning off the red light if it is on. Right, and if your status is busy, and if you're do not disturb, so this is what it happens, right? So that is the end of it. And now let me quickly turn on the pins, which is connected to pin number 12 and pin number 13, if I'm not wrong. Yes, it is 13. So now .NET run. Yeah. Okay. So I've already told you that we'll have to log in. Right. So let me quickly log in because it is a device code flow. You can log in with this code on any device in order to authenticate. Since I'm using device code flow is because I'm now remotely connected to the Raspberry Pi. I don't have a browser, the browser on the Raspberry Pi at this moment, right? So with the help of the device code flow, I can use this code anywhere, which I'll be doing it in a moment. So what all needs to be done is you'll have to use this URL device login and enter the code which was generated. Right now, login, and then whose presence the application has to get. It's my presence right now, right? So I'm logged in now, and if I go to the application here, Just a moment. Yeah. So you can see here, my status is user not to be disturbed, right? And it actually polls the graph once in 5 seconds. You can see here, and I will quickly show the lights as well. Yeah. So I will. Okay, you can see here the light is red because my status is busy or do not disturb. So I will change my status, the team status, to green, available. So you can see here the light. Okay, sorry. Yeah, you can see here the available. The green light is turned on. The red light is turned off. I'll switch it back again to the status where I was before. Do not disturb. Yeah, it will now quickly turn on the red one, and the green is turned off. You can see here. Right, so I think I have completed it for the Teams present slide. So let's now quickly go back to the presentation mode. Yeah, the last slide. Yeah. So the references and whatever references I've used, I've put it on the slide, and also the slide has been uploaded to slideshare.net. We'll be we'll be providing this URL shortly, and whatever content you have seen on the slide will be there. You can get that slide, right? And also, I'm actually writing a blog post on it. It's not completed yet. I've just started it. And you can expect this maybe in a week or so for both the present slide and also to start your IoT project with .NET Core, right? And whatever I've shown you, how to connect, remotely connect, and everything will be documented. And whatever commands I use, everything will be documented on. I'll be publishing that on this URL, ashikf.com. That's my blog site. And also all the codes, be it the function app code, the console application, everything will be, I'll be storing it on the github.com. Right now it is not done, but I'll be doing it. So now questions, and before we actually start this one, I would like to let everybody know that I'm not an IoT expert. I've started exploring it recently and thought of sharing whatever knowledge I have gained, right, to everybody here in the community. And if you have got any questions with the setup here, you can ask me. And if you got stuck anytime, you can send me. You can send a message on LinkedIn or send an email, right? You can contact me. And if you're stuck somewhere, please let me know. I'll be happy to help. And if you've got any questions on the app, whatever I have developed or shown you, you can ask now. Unmute yourself and ask.
Yeah, Ashik, yeah, I think, Hasan has started the question. What is the model version of Raspberry Pi we used here?
A Raspberry Pi 4, and it has got a 4 GB RAM.
Okay. So, guys, please ask your questions. Anything.
Unmute yourself. Ask me any questions related to what I've shown you now. Don't be shy.
Hello, hi, Ashif. This is Umar Basha. First of all, I would thank you a lot to you, like for exploring IoT on Microsoft platform. That's really appreciable. I have few questions. The first question is like, what would be like, what is the challenge you might have got when we are doing the production when we are using PowerApp? As I know that I can think that PowerApp can be used as a front-end kind of device. So is there a chance to replace PowerApp with any other open source or any other app like cross-platform, like React Native or Flutter?
Absolutely. And so what we are all use to send messages in Azure Function. So you have an endpoint, right? So from your Azure React app or so, you'll have to just call that function endpoint. You'll have to make a GET request, and if you make a GET request, the light will be turned on, right? Based on the message you send on that request URL. You can call it. You can use this. Use Azure Function app endpoint on a website, right? And even within Microsoft 365, for example, if you want to control, turn on the on or off the devices from a SharePoint site, you can do so by extending with SPFX. You know that SPFX uses React, right? It can be easily done.
Thank you. I have other set of question also, but I will let other people to ask first.
Sure.
Later, I will ask other set of questions.
Yeah. Anybody has got any questions? You can go ahead with your questions. Basha.
Okay.
Yeah, Umar.
Thank you. Coming to the other part was I have observed that we are using Azure platform extensively. What are the advantage of using Azure platform, specifically using Azure Function and IoT Hub over there, and how many request response can we have over there if we are releasing to production, and what would be the minimum price estimation of devices which can be connected for the minimal price? I'm asking.
Okay. So to answer your question, there is a pricing calculator for Azure pricing. You can go look at it on Google and add the service. And in our case, it's going to be IoT Hub. And whatever tier I've used is a free tier, right? And with free tier, you can send up to 8,000 messages per day. And if it exceeds beyond that, it will not work because we are in the free tier. But if you want to run it on production where you expect more than 8,000 messages per day, in that case you'll have to choose a different tier. So there are standard tiers, and you can get to know the cost right on the portal on the pricing calculator in Azure. And coming to your other question on the function app, and it is a consumption based plan. Right, and there is also a lot of free requests you can make on an function app, right? And if you exceed beyond that, only after that you get charged, right? And you can get this information as well on the pricing calculator in Azure. So go to Google pricing calculator Azure, you put it, add the service IoT Hub, and add a function app. You get to know the cost.
Okay, thank you. That's useful. During the second project, I observed we were using Microsoft Graph, which is basically to connect all different Microsoft products, products like Teams and other products. So what kind of use cases, other use cases, can you think with respect to IoT can come up when we are using Azure Microsoft Graph?
At this moment, I don't have on the top of my head. Maybe I will get it later, right? So the reason I've planned for this Teams Presence Light is because we are now almost everybody is working from home, right, due to this COVID situation. And while doing it, and if you're working inside your inside a room, and outside you're going to have a light, and based on your current team status, you turn on or off different color lights so that people outside the room gets to know that you're busy or you're available. You can get inside the room, someone can get inside, and that is the one use case which I've chosen. Maybe coming to with Teams as a platform and using IoT is, but not with Graph. If you want to control devices right from Teams, Yeah, right. You send a message on a channel, the light gets turned on. You turn on the lights gets turned on. Right. You turn off the light. You put a message on the Teams. The light gets turned off. Right. So this can be easily done by creating a bot, a Teams bot, which in turn calls the Azure function endpoint. And this is something which can be done, but there might be other use cases using a graph, but I'm not currently aware. It's not on my top of my head, right? Maybe the IoT guys, right, who gets all these requests, they might be aware of, IoT experts.
Yeah, along with that, I can add one more use cases, because nowadays, like all the classes and like there are in the college also, everything they are conducting their classrooms via Teams only. To explain the kids or like whatever the students means, they will use most of that augmented reality classes, and as well as like there might be like some of that devices also. Those kind of the things right now you can use the similar kind of feasibility to like elaborate the students in with the device along with the augment features. Then you can use the same kind of architecture. So that will help to the students, and that even for that kindergartens, they will understand easily that concept, how they are getting the similar kind of experience in the face-to-face classes. That is the biggest use cases we can leverage in this IoT project.
Okay.
Yeah.
Thank you. My next question would be basically when we go for a in general, when we go for an IoT production, the hardware is like custom made hardware, where we will be using primarily we will be making our own hardware device using some PCB device software, and we will be designing our own hardware. In that case, we generally prefer to go with C++ language. So if we are going with a C++ language and not a .NET Core platform, which is not C#, how feasible is, how much feasibility is there for us to use Azure platform, the same platform in the C++ part of platform? Yeah. I hope,
Okay.
Yeah.
Okay, so there are libraries for Python, right? So whatever we have done to control devices, right, through the GPIO pin, there are libraries for Python. There are the libraries which we have used here is the system.device.gpio, which is a .NET library, and there are also libraries for C++. Right, so instead of the console application, which is a .NET, you'll have to have a C++ application, right? Which I have not tried yet, but there'll be definitely a possibility to run on an Linux, right? The Raspbian operating system, which runs on the Raspbian operating system, right? It is a Linux-based operating system. So it will be definitely feasible. But as your question, if there is a custom hardware, and if your custom hardware has got a capability to run C++, then you can easily call the receive the message. There are libraries from Microsoft.NET to you from Microsoft Azure to use the different for using in different programmatic languages. Right, there are for example on the references here, I've used the library for Python, right? So this is for Microsoft.identity.client. This is the MCL library, Microsoft authentication library. But there'll be versions for C++ as well. I remember seeing it, and when it comes to this one, okay, I forgot the name. This system.device, no, not yeah, there might be this particular version for C++ as well, right? And the Microsoft devices, Microsoft.azure devices. So there'll be definitely a library for C++ created by Azure in order to receive the message from the IoT hub.
Okay. Thank you.
To adding that point, there is a SDK is available. I already pinged that SDK in the chat for supporting the C++. So there, yeah, that's why I'm saying C++, C are very basic languages. Definitely, we have a SDK. So using the SDK, you can control the device.
Yeah. Okay,
Thank you.
guys. I think we will close the session now. Hope you have learned something new. I'm repeating it again. If you're starting an IoT project, if you're kickstarting it, if you got any questions related to what I've shown you, don't hesitate to ask. You have my handles on the slide, LinkedIn, email address. Contact me. I will help you. And before that, I will quickly, and also I've said we have recently started this user journey group, and we are planning to do these sessions in the future. One is there are different types of authentication flows in Graph. Right, and if you based on the different application permissions or delegated permissions. So I'll be giving an walkthrough, right, with all these different types. I will be creating an event on the group, so do look at it. If you find it interesting, join. And we are also planning for one more session on-premise data gateway, how to get a data from your on-premise, right? Not on the cloud. Not so. Let's take an example. You have got an SQL table on-premise, SQL database on-premise, and if you wanted that data on your Power BI, right? So how to get it? So we can get it through the help of a Power Gateway, data gateway. And also we'll be showing some artificial intelligence in Power BI, some features. So Trinav Karsu, who is also co-hosting the session, he'll be showing that. Right, so these are our upcoming sessions, and we'll be posting, creating events on the Cloud Journey user group. So spread it to your friends about this group. You will get new learnings, right? So that's it from my side. I'll go to the last slide, which is a thank you. That's it from us today.
I think we have shared the feedback link also. Please guys share your feedback. I think I can share that one more link. Yeah. If anyone facing issues, yeah, please let us know.
Okay, so thank you so much again. Have a good Sunday. We have one more day for the weekend to get over. So thank you so much again. Bye bye.
Thank you.
Bye.
Thank you.
Thank you.